Hi everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about testing proportional relationships using a table. Let's jump in. All right, here's an example of a table that has many ratios. They all have the same proportional relationship. What two numbers do you think will go in the last ratio? Do you see any patterns? Let's take a look. You've got 1 to 3, 2 to 6, 3 to 9, 4 to 12, 5 to 15, 6 to 18, 7 to 21. What do you suspect will go in those last two boxes? If you need to, go ahead and pause your video and grab a pencil and write it down. We'll see you in 1 sec. All right, everyone, how did you do? Did you get 8 and 24? Did you see the patterns? Let's take a look. What were the patterns in that table? Well, the first pattern was that the top row increased by 1 each time. Let's take a look. 1, 2, 3, 4, 5, 6, 7, 8. Also, the bottom row increased by 3 each time. 3, 6, 9, 12, 15, 18, 21. So our next number would be 24. And then the third pattern that I was hoping you'd pick up on is that to get from the top number to the bottom number in each column, you would multiply by 3. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and so on and so forth. So let's take a look at these 3 patterns. They actually are our 3 tests that will help us when we're looking for proportional relationships. Let's take a closer look at these 3 tests. Test 1. The top quantity of the ratio increases at the same rate each time. Basically what we saw in pattern 1, the 1, 2, 3, 4, 5, 6, 7. And here's what I wrote. That increases by 1 each time. Test 2 is that the bottom quantity of the ratio increases at the same rate each time. That row increased by 3 each time. 3, 6, 9, 12, 15, 18, 20, 21, I'm sorry. And test 3 is that the relationship between the two quantities must be the same. We multiply the top number by the constant of proportionality. Remember, the constant of proportionality is the numerator in our unit rate. In this example, it was times 3 to get the bottom number for each column. So 1 times 3 is 3, 2 times 3 is 6, and so on and so forth. So those are our 3 tests. Let's take a look at an example. And this one is something you might see in the real world. Okay, storm chasers collected data to show the relationship between the time you see lightning and hear thunder and how far away you are from the lightning. The results are in the table on the next slide. Is there a proportional relationship between lightning and thunder and how far you are away from the lightning? And then it says justify your answer. And what that basically means is that the question just is asking you to explain why or how you came up with your answer. Okay, so here's our table. We've got the time between lightning and thunder. We'll go across the top. 15, 25, 35, 45. And the distance from lightning on the bottom, 3, 5, 7, 9, and 11. Okay, now let's take a look. Let's try our first test. Remember, our first test, what we're looking at is, does the first row increase by the same number each time? So we had 15, and the next number was 25. We added 10 to 15 to get 25. And the next number is 35. Now you're probably seeing a pattern here. 15, 25, 35, 45. Each time, it increases by 10. So yes, in fact, this does pass the first test. All right, let's try the second test. Does the bottom row increase by the same number each time? 3, 5, 7, 9, and 11. Well, yeah, in fact, it does. Because 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, and 9 plus 2 is 11. So yes, that does pass. This table does pass that test as well. All right, and our third and final test is the ratio the same between the columns. So we've got 3 times what equals 15? 3 times 5. 5 times what equals 25? 5 times 5. You're probably picking up on the pattern, and you're going to notice that yes, this does in fact work. That we are able to multiply by 5 each time to get the number on the top. 9 times 5 is 45, and 11 times 5 is 55. So because this table has passed all 3 tests, we know that it does in fact have a proportional relationship. All right, everyone, thanks so much for joining us today. We'll see you next time.